Hello everyone. This video would focus on conic section, specifically on ellipse with center at the point of origin or at 0, 0. And this is the fifth part. In this part, we're supposed to determine the standard equation of an ellipse given the coordinate of the two foci and the coordinate of the two vertices. But before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at 0, 0 or at the point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always, every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex, and we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under, or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that, again, our A is always greater than B. Now, to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now let's go back to the problem. Okay, going back to the problem right here. So we are given the coordinate of these two foci and the coordinate of these two co-vertices. So we're going to start by plotting the coordinate of the two foci. So that's going to be square root of 13, 0. Now, if we are going to change this square root of 13 to decimal, that would be 3.61 and then 0. And then this is negative 3.61 and 0. So it's going to sit down here. So 3.61 positive on the x. So 1, 2, 3, 3.61. So this is our first focus. And then the other focus is on the other side across. 1, 2, 3, 3.61. So it's going to sit somewhere here. So this is our other focus. Now we are also given the coordinate of the two co-vertices. So it's going to sit at 0, 6. So the y is going to go up here. So this is our first co-vertex. And then the other co-vertex is 0, negative 6. So I'm going to label this as co-vertex here. Now, we remember that the center of an ellipse is the midpoint between the two vertices or the two co-vertices, or the midpoint between the two foci. So that from here, we can go ahead and use the midpoint formula to determine the midpoint between these two co-vertices. Or we can just go ahead and trace it. Our center right here is at the point of origin, or 0, 0. Again, we can use the midpoint formula to determine the center. It's still going to be the same by tracing it up. So we go ahead and write, or we go ahead and label this point right here as our center. Now, looking at this, we see that our two foci, or the coordinate of the two foci, is on the x-axis. So that we can go ahead and say that our major axis is the horizontal line. So that this kind of problem is an example of a horizontal ellipse. So I'm going to go ahead and write that information up here. Okay, since this is an example of a horizontal ellipse, we can go ahead and write the general equation of horizontal ellipse. That's actually x squared over, since our major axis is the horizontal line, then at the bottom of the x squared, or the denominator of the x squared, should have an a squared on it, and that would be plus y squared over b squared equals 1. So that we can go ahead and determine what are the values of a and what are the values of b. Just by looking at this given that we have right here, we are given the coordinate of the co-vertex. So this is our co-vertex right here. Now we remember that the distance from the center to the co-vertex is represented as letter B. So I'm going to go ahead and write that down here. So this letter B. And so we can use the distance formula to determine the distance from the center to the vertex, or we can go ahead and count it. 1, 2, 3, 4, 5, 6. So that means our B value is 6. So plus minus 6. So we already have a value for b, so we plug that in here. So that is x squared over, we don't have the a yet, plus y squared over our b is 6. We write 6 squared for that is equal to 1. So we're missing the a. Now we remember that our focus here is located on the x-axis. Now we remember that the distance from the center to one of the two foci is represented as letter C. So we can go ahead and say that our C value here is from the center to the focus. Remember that this point right here, or this other way right here, this is a C. So this is actually located at square root of 13, 0. That means that the distance from the center to the focus is square root of 13. So I'm going to go ahead and write that up here. So plus minus square root of 13. So this means that we can use this value for C to determine the value for A. Now, this A, B, and C has an equation that relates to all these three, and that is C squared is equal to A squared minus B squared. So I'm going to go ahead and write that up here. Okay, so plugging in the value, we have a C. So I'm going to put in the C value right here. So that is square root of 13 squared equals our A squared is missing, and that's what we're looking for. A squared is equal to our B was already 6. So I can put that in here. So that's a minus. So minus 6 squared. So this becomes square root of 13 squared is just 13. And that is A squared minus 36. We want the A, so that we can go ahead and add 36 from both sides, plus 36. So this comes out, we can cross this out. So this becomes 49 equals A squared. This tells us that our A then is plus minus 7. So that means we go ahead and count 7 steps to the left and 7 steps to the right. So this is the point for the first vertex, and this is the other vertex up here. So I'm going to label that as letter V. So plus 7 minus 7. Okay, so we can go ahead and plug this 7 value up here. So I will put 7 squared. So we can simplify this as x squared over 49 plus y squared over 36 is equal to 1. And this is the equation for this ellipse that we have in this problem that we have up there. So we can go ahead and write the coordinate of the two vertices down here. So this is the equation for this problem that we have right here, and this is the graph of this ellipse that we have down here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're supposed to determine the standard equation of this ellipse. We're given the coordinates of the two foci and the coordinate of the two co-vertices. So I'm going to go ahead and plot these 4 points up here. Okay, now we remember that the center of an ellipse is located in the midpoint between the two vertices or the two co-vertices. So if we trace this, again, we can use the midpoint formula to determine the midpoint, or we can just trace it. So in this case right here, we can tell that our center is located at 0, 0. So this is our center right here. Since our focus is on the vertical y-axis, we can go ahead and say that this is an example of a vertical ellipse. So I'm going to go ahead and label that information up here. Okay, so I wrote the general equation of a vertical ellipse. Now we remember that this co-vertex, which is down here, the distance between the center and the co-vertex is represented as letter B. So I can go ahead and write that down here. So that's a B. Counting this, that would be a 5 and 5 on the other side. So our B is plus minus 5. Now, this distance from the center to the focus is represented as letter C. And so we can go ahead and say that the distance from the center to the focus, again, in this case right here, is, if we say that the coordinate for this is 0, 2 square root of 14, if we use the distance formula, we can say that our C is plus minus 2 square root of 14. So that we can go ahead and plug in the value for B down here. So the equation would come out. Now we don't have a value for A, but we can solve for A using the values of B and C, so that we can use the equation C squared equals A squared minus B squared and solve A from there. So I'm going to show the work down here. Okay, so we can go ahead and say that the value for A is 9, or A squared is 81. So I can go ahead and write that up here. So that is 9 squared. And so our final equation would come out. Okay, so we go ahead and plot the vertex for this problem. It's located 9 units from the center. So we go up 9 and we go down 9. And that is where our vertex is gonna sit. By the way, this one right here is our co-vertex. So I'm gonna change this to co-vertex and co-vertex. Again, that was from here, 5, 0 and negative 5, 0. So these two, that should have been a co-vertex. So that we can go ahead and draw the ellipse. Okay, did you get the same answers as this? Good, perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!